Okay, in this video, I want to talk about process control. So, what is process control? It's basically controlling a system. And there's engineering stuff that is available, and engineers use this, process control techniques all the time to control systems. And there are theories that explain how to do this. I'm not going to go into detail. There's some references if you want to go look at it. But the first thing that most people do is they make a fundamental mistake that they define the system from their perspective. And, so somebody creating an application to create a financial report, they look at the system as their application. So that's basically silo thinking. The system is really everything combined, and if you don't control that, it's not going to work. So the first thing you have to do is, first understand what a system is. A really good way to understand systems is to watch this video. A theory of systems. This is provided for educators, and it basically helps educators understand that the stuff that Edward Deming was doing for manufacturing also applies to education. Well, it also applies to accounting systems. So the thing that you need to do is, what is the aim of the system? What is the ultimate goal of the system? And that aim must be managed. For example, if it is the case that it is the aim for the SEC to make it easier for analysts and investors to extract information out of a report, you must manage every step in the process to make sure that that happens. And the SEC is not doing that, and that's why SEC filings don't work. But it doesn't have to be that way. If you think differently, you can make it work. Really straightforward. So, also, software developers tend to not be engineers. They're people that know how to code. They don't think like an engineer, and they don't understand how to control computer systems. They don't even understand what needs to be controlled. So there's this paper, An Introduction to Systems and Control Theory for Computer Scientists and Engineers, that points this out. Software engineers need to use control concepts to master the ever-increasing complexity of computing systems. So creating a financial report is a complex computing system. So first, you have to understand the difference between an open system and a closed system. So basically, you can control a closed system. You can also control an open system, but it's way harder, an order of magnitude, or if not multiple orders of magnitude harder. So XBRL plus SBRM together is a closed system. SBRM constrains XBRL in a manner explicitly to make it a closed system. So the way you create a process is you define the process. For it to be able to define it, you have to have boundaries, and basically boundaries is how you create a closed system. And that's what you have to do to make it able to manage the process. So also, there's this rule, 1, 10, 100. And this rule basically is a way to talk about efficiency. So the idea is that it takes $1 to prevent an error. It takes $10 to correct an error if you didn't prevent it in the first place. And it costs $100 if you have a failure because you did not correct the error, because you did not discover the error and prevent the error. So saying this another way is an ounce of prevention is worth a pound of cure. This is pretty straightforward stuff, but people are not thinking in this manner generally, and that's why their applications don't work correctly. So another thing, again, Deming in that video, he talks about, at the time, it was called world-class manufacturing techniques. Now it's called Lean Six Sigma. So Lean Six Sigma takes the ideas of Six Sigma and lean manufacturing, puts them together, and it is about process control, quality control, controlling quality. So the bottom line is these Six Sigma philosophies and techniques don't only work for manufacturing processes, they also work for information processing processes. So that's what I'm doing here in the systems that I'm creating. So this is a business requirement. It is a business requirement. No business professional would tell you that they don't care about whether the application is doing the right thing or not. Of course, you have to have guaranteed performance. You have to have stabilized processes. You have to have reliability. You have to have predictability. None of these things are a good thing. Business people don't like where you don't know what you're going to get. The processes are not stable, they're not reliable, and they're not predictable. It's absurd to think otherwise. So basically, this is the system. You have accounting, which feeds reporting, auditing process, pulls information from a report and also from the accounting system. And the analysis process uses information that has been audited. So, I can change these diagrams around a little bit. They're not necessarily perfect, but it's more important to understand the idea that the system is all of this. It's not just one piece. And if you cannot do the analysis, something is wrong in the system that has to be fixed in order to make it work correctly. So let me walk you through this in another way. So here's the bigger, this is kind of an abstraction of what's going on. This is more details about what's going on within a system. You have data and it moves through the system and you do the report. So this is the details. We're not going to need to go at this level. I'm just showing the overview. But basically, the end of the process is analysis. So here, you see I've gotten a bunch of information pulled out of a report, and it's all verified to be correct. You don't see any indications that there are mistakes. Okay, so basically, if I am an investor and I want to pull information out and I can do so effectively, then the system seems to be working. Okay, so part of this is making sure that nothing goes wrong. So here, you have all these different things that can go wrong. You check, and every one of these reports is correct per this constraint. And if you do that effectively, then the system works. You've controlled the system, and it does what it's supposed to be doing. So I'm going to show you one piece. I'm not going to show you all of these different things. It's the same idea for every piece of what you need to control. So, here's the report. Here's the process for entering the journal entries that create the report. This is the system. So you basically have an accounting system that provides information that ultimately ends up in a report, and then it gets extracted by analysts, and that's the system. You have input, processing, and output. And an input for one phase could be the output for another phase of this system. So what's going on here? So this is what the SEC filings look like. The red are catastrophic errors. They're basically XBRL errors. The orange are logical errors. They're not catastrophic errors because some pieces of a report can work correctly when you see these specific errors. These tend to be catastrophic errors. If you can't read the XBRL, then then the document is fundamentally unreliable. But most of these are not really that catastrophic. They're HTML errors, HTML coding errors. But anyway, the point is that there's things going on. That's why you can't use the information effectively. It's not been controlled. So here, these are all the disclosures in a report, and everything here is good. Every disclosure was found, and everything is consistent. And there are processes to check for this. So it's done using rules. There's a rule. And this is a line of reasoning where the computer used the rule to grab this information. And you can see that everything is checking out effectively. So that's what process control is about. I am controlling the process and making it so when I create the report, every disclosure is created correctly. So therefore, an analyst using the same rules can extract information from my report, and basically you control every aspect that is important to control to make sure everything is correct, and that is how you create a properly functioning logical system. So I'm going to call that good.